That this is amongst the most excavated and most studied archaeological sites in the entire world.
Deep inside the Great Pyramid of Giza, sitting directly above the king's chamber, there are 5 narrow rooms almost nobody ever gets to see. Each one is stacked with granite beams so heavy that a single block weighs as much as a school bus, and one of those beams is cracked straight through. It's been that way for 4,500 years. So how did the Egyptians lift these enormous blocks more than 40 meters above the ground and position them so precisely? And more importantly, what caused one of them to crack? Archaeologists have spent centuries trying to answer questions like these, but the evidence is scattered across decades of research. So researchers tried something different. They gave that evidence to an AI system called Grok and asked it to look for patterns and connections researchers might have missed. In today's video, we'll walk through exactly what Grok found. The researchers who had already noticed some of these clues decades earlier, and why the story of the pyramids might be far bigger than one pharaoh. Let's get into it. The official story. For more than 4,500 years, the Great Pyramids have captivated every tourist who has stood before them. Their size, their precision, and the sheer amount of work that went into building them make you stop and wonder, how could humans have built something like this more than 4,500 years ago? For more than 2 centuries, archaeologists have slowly pieced together an answer. And it begins with one pharaoh, Khufu. Around 2560 BCE, Pharaoh Khufu ordered the construction of what would become the Great Pyramid of Giza. The pyramid was meant to serve as his tomb, but building it was far more complicated than simply stacking stones. First, the Egyptians quarried the stone, cutting massive blocks directly from the limestone quarries around Giza, while finer limestone and granite came from much farther away. Then they transported the blocks by boat along the Nile and dragged them across land on wooden sledges. Finally, and perhaps hardest of all, they had to lift these massive blocks higher and higher as the pyramid grew, most likely using ramps and ropes. It was an enormous operation, and archaeologists eventually found evidence of exactly that. Beginning in the late 1980s, excavations south of the pyramids uncovered what became known as the Lost City of the Pyramids. This was a purpose-built settlement where laborers, craftsmen, administrators, and other workers lived and worked while the pyramid complexes were being constructed. Archaeologists found bakeries, workshops, storage areas, animal facilities, houses, administrative buildings, and evidence of large-scale food production. For centuries, people believed that armies of slaves were forced to drag stones through the desert. But the archaeological evidence points towards something much more organized. These were workers supported by an enormous system of food, housing, transportation, administration, and skilled craftsmanship. And there is another remarkable piece of evidence. Ancient papyri discovered at the Red Sea port of Wadi el-Jarf include the diary of an official named Merer. He described his team transporting limestone by boat toward Giza during the reign of Khufu. For the first time, we have something remarkably close to a first-hand account of the logistics behind the Great Pyramid. So we now have a much clearer picture of how and why these pyramids were built. But once you enter the Great Pyramid and look deeper inside, things become much harder to explain. Because hidden within those massive stone walls are passages and chambers that archaeologists still haven't been able to fully explain why they were built, or exactly what purpose they were meant to serve. The hidden chambers. The king's chamber sits high inside the Great Pyramid, and directly above it is a stack of 5 small chambers, one above another. The first was discovered in 1765 by British explorer Nathaniel Davison, who noticed a strange echo while exploring the passage below. More than 70 years later, Egyptologist Howard Weiss forced his way into 4 more chambers using gunpowder. Inside, Weiss's team found something that would become one of the most important pieces of evidence connecting the pyramid to Khufu. Painted onto the stone in red ochre was a cartouche, an oval containing a royal name. Inside it was the name Khufu. It was conclusive evidence that the Great Pyramid was built during Khufu's reign. But there was something even more remarkable. Hidden inside the chambers were massive granite beams. They weighed as much as a school bus. Yet somehow, the Egyptians had raised these enormous blocks more than 40 meters above the ground and positioned them directly above the king's chamber. But why did they go through all that trouble in the first place? That is because the entire weight of the pyramid comes crashing down onto the king's chamber. The granite beams were placed directly above that chamber to help divert that weight away and to the sides, rather than allowing it to come directly down on its ceiling. But then there's another detail. One of the granite blocks in the lowest chamber is fractured straight across. Researchers have debated what caused the damage for centuries. One explanation is earthquakes. The Giza plateau has experienced seismic activity over thousands of years, and the fracture could have developed long after the pyramid was finished. So, at least we have an explanation for the crack. But what about the other mysteries connected with these beams? How did the builders transport these granite beams 40 meters in the air? And if this is truly the first monument Egyptians had constructed at such a massive scale, how did they know the exact position the beams needed to be in to divert the weight of the pyramid? When it comes to these questions, archaeologists are just as clueless as anyone else. Because according to conventional history, the only tools the ancient Egyptians had at their disposal were chisels, hammers, and ropes. They had no modern machines, such as a crane, to lift the heavy beams, and no technology to tell them the exact positions the beams needed to be in. Yet the beams are there, exactly where they needed to be. In an attempt to answer these questions and understand how ancient builders made the pyramids, modern researchers began measuring the dimensions of the pyramids. They hoped it would give them some answers. But the numbers that came back only left them even more confused. The perfect dimensions. When modern surveyors began measuring the Great Pyramid in detail, they discovered that the precision of the structure was almost as remarkable as its size. The first major breakthrough came from British archaeologist William Flinders Petrie. He conducted an exhaustive survey of the pyramid in the 1880s, and what he found was extraordinary. The enormous foundation of the pyramid covers more than 5 hectares. It was almost perfectly level across that entire area. We're talking about a structure built more than 4,500 years ago, covering an area larger than several football fields. Yet the difference in elevation across its foundation is only a matter of centimeters. And the precision doesn't stop at the ground. The 4 sides of the pyramid are aligned with the cardinal directions, north, south, west, and east, with extraordinary accuracy. The deviation from true north is only a fraction of a degree. Even for a modern structure, that would be impressive. For people working thousands of years before compasses, satellites, or electronic surveying equipment existed, it is unbelievable. So, how did they do it? Researchers say that the Egyptian surveyors could have watched the movement of circumpolar stars and used their positions to establish a north-south line. Because these stars remain visible throughout the night, they could provide a reliable reference without a compass. For the foundation, the popular theory is that they could have used water. A network of trenches filled with water could have provided a level reference across the construction site. Water naturally settles to the same height, giving the builders a way to identify high and low points and gradually align the entire foundation. Both techniques are plausible, but there is a problem. We are reconstructing the process after the fact. We can measure the finished pyramid down to astonishingly small differences. We can propose methods that could have produced those measurements. But we don't have a complete record showing us exactly which methods the builders used, how they organized them, or how they checked their work as the pyramid rose. We're looking at the final result and trying to reverse engineer the process that created it. That is an important thing to clarify, because knowing what they achieved is not the same as knowing how they achieved it. And for centuries, we have tried to fill that gap with educated guesses, archaeological evidence, and modern experiments. But in 2025, researchers finally found a way to close that gap: Grok AI. The AI analysis artificial intelligence has given researchers a new way to examine things. What if we tell a machine to search through all of the evidence available and look for relationships humans might have overlooked? That was the idea behind the analysis using Grok. The system was given measurements from the pyramid, including its dimensions, internal chambers, passages, angles, alignments, and proportions. It was not told what it needed to find. The only instruction was to look for patterns and relationships within the data. One of the first things the AI identified was the mathematical number pi. That sounds like a major discovery, but it wasn't entirely new. Researchers had noticed a relationship between the pyramid's proportions and pi long before artificial intelligence existed. There are also conventional explanations for how a similar proportion could have emerged from the way Egyptian builders measured slopes and distances. So pi alone doesn't tell us very much. The interesting part came next. When the analysis turned to the king's chamber, it reportedly identified another mathematical relationship. This time, it involved the golden ratio, the number 1.618. What's more, the relationship wasn't being pointed out in the overall dimensions of the pyramid. It only appeared within the measurements of the chamber itself. Now we have two familiar mathematical constants appearing in different parts of the same monument. And that's where the question becomes much more interesting, because there are several possibilities. The builders could have deliberately designed these proportions. They could have arrived at them through practical methods without thinking about the mathematical constants we associate with them today. Or some of the relationships could simply be patterns we discovered after examining thousands of measurements. Whatever the case may be, they were still numbers contained within a single building, and the analysis was giving researchers no breakthrough. So, they took a step back and expanded the analysis. Instead of asking what patterns existed within the pyramid, they started asking whether the pyramid's location itself was part of a larger pattern. The Global Link researchers gave Grok the pyramid's exact geographical coordinates and asked it to look for patterns in the location. The AI produced another striking numerical relationship that made scientists rethink their whole approach to studying the pyramids. It began tracing geometric relationships outward from Giza. It traced lines across the earth. They passed through other ancient sites, monuments that were separated from Egypt by enormous distances and, in some cases, by thousands of years. But a line drawn across a map can be made to pass through almost anything if you choose the starting point, direction, and destinations carefully enough. Finding a geographical connection doesn't automatically prove that the builders of these monuments knew about one another. So why did these connections interest the researchers? Well, the fascinating part wasn't that the AI connected the sites. It was that the relationships kept repeating. Distances between sites appeared to fall around recurring ratios and fractions of the Earth's circumference. The mathematical relationships can potentially be explained by the way its builders measured and constructed it. But how do you explain the fact that its location was deliberately chosen according to other ancient monuments? To do this, someone would have needed to know where those other places were. They would have needed some way of measuring massive distances across the Earth's surface. And they would have needed a reason to arrange monuments according to those relationships. That is much harder to explain. And the AI wasn't finished. It found something even stranger when it compared the quality of construction across these sites. The precision didn't appear to increase with time. it declined. And if that pattern is real, it turns the conventional story of technological progress completely upside down. The wrong direction. Once we consider the possibility that the founders of the pyramids were gradually losing their skill, the story becomes much more unsettling. Because Grok didn't just compare where the ancient sites of the world were built, it also measured how they were built. The angles, the joints, the measurements, the way enormous stones were fitted together. And the AI's analysis showed something that stunned scientists. The oldest sites weren't the crudest. They were among the most precise. That is the opposite of what we expect to happen. Archaeology says that human construction moves in one direction. First, we have crude tools, then better tools and better techniques. As knowledge keeps on building and precision improves, the structures become increasingly sophisticated. The Great Pyramid should therefore represent the end of a long process of learning and experimentation. But the actual pattern that the AI found runs the other way. The further back the sites were dated, the greater their precision became. Then, as the monuments became younger, that precision declined. The joints became less exact. The angles became less consistent. The workmanship became rougher. It was as though the builders weren't gradually discovering better techniques. They were losing them. This forces us to rethink everything we thought we knew about the pyramids. We thought the Great Pyramids represented the peak of the Egyptian era's engineering at Giza. What it's actually showing us is humanity desperately trying to preserve knowledge that was already vanishing. The Egyptians were clearly capable engineers. They knew how to quarry stone, move it, organize thousands of workers, and turn large quantities of raw material into a single structure. But perhaps some of the techniques behind their most precise work had already existed long before the pharaohs. If that's true, then we have to ask where that knowledge came from. Searching for the answer to that question takes us back to a time when the last ice age was ending, when glaciers were retreating and sea levels were rising. At that time, many of the world's oldest civilizations had not yet appeared. That is where the story takes its unexpected turn. Because now the question isn't simply who built the Great Pyramid. It becomes who taught its builders how to build it. The lost knowledge. Around 12,000 years ago, the world was being reshaped by melting glaciers and rising sea levels as the last ice age came to its end. Coastlines that had been inhabited for generations were being flooded and pushed underwater. A settlement built beside an ancient seashore could now be buried beneath layers of sediment or underwater. Buildings made from wood, mud, or other fragile materials could disappear completely. It is possible that a community could have developed extremely advanced techniques that disappeared underwater without leaving any evidence behind. But what if some of that knowledge survived in the memory of the people and was passed from one generation to the next? According to the AI's interpretation, some of that knowledge reached the Egyptians, and that is how they were able to make the pyramids. And this is where the Egyptian record itself starts to support this theory. The Egyptians were obsessed with recording their world. Their temples, tombs, statues, and monuments are covered with names, titles, inscriptions, and records of what they accomplished. Yet, we don't have any Egyptian inscription explaining how the Great Pyramid was designed and constructed. That absence could be because some of the methods were inherited rather than invented. The builders may have known how to use them without knowing where they originally came from, or how to explain why they worked. And that brings us back to the question at the heart of this entire story. Who actually built the Great Pyramid? And where did their knowledge come from? There are three ways to look at it. The first is the conventional explanation. Khufu's workers designed and built the Great Pyramid around 2560 BC, using mathematics, astronomy, and construction methods refined through generations of Egyptian building. The second possibility is more subtle. The Egyptians still built the pyramid themselves, but some of the knowledge they used may have come from earlier builders whose monuments and records have disappeared. In this version, the pyramid is a masterpiece of preservation rather than sudden invention. And then there's the third possibility, the one the AI points toward, that some of the knowledge behind Giza stretches back before the pharaohs entirely, to a period near the end of the last ice age, with Egypt's builders serving as the last link in a much older chain. And if that possibility turns out to be true, then the mystery isn't simply how the Egyptians built the pyramid. It's how much of what they knew had already been forgotten by the time they built it. Grok made the mystery of the pyramids much bigger, because if this knowledge is older than the pharaohs, then Giza may be the end of a story that began thousands of years earlier. So, what do you think? Does knowing the real math and the real construction history change how impressive the Great Pyramid feels to you? Or does the mystery still pull you in either way? Let me know your thoughts about this in the comments below. And if you enjoyed this video, make sure to like, subscribe, and turn on notifications so you never miss the next mystery we dig into. Thanks for watching, and we'll see you in the next video.